So again, you've got the information about the Mentimeter, and you can join the Mentimeter even right now if you want to feel free to respond to those questions as we progress with the presentation. So first, I want to talk a little bit more about the transition technologies. It's a multinational company with most of the offices based in Poland, but also some other locations, including US and mainland Europe, as well as United Kingdom. We've got over 500 specialists that are available for different projects and helping customers. For that reason, we have made over 20 million euro in revenue for 2012. And we also have over 200 references from our existing clients. All right. So today's hosts will be myself and my colleagues. I'm a lead Azure architect. I specialize in migration of large and even smaller projects to Microsoft Azure, as well as different other Microsoft Azure technologies. I've got over 20 years of experience in software development, and there would be also two of my colleagues, Adam and Piotr. So I believe they would be able to. They would be happy to introduce themselves. Adam, over to you.
Yeah. Hello, everyone. Thank you, Maciej. My name is Adam. I'm a software engineer working for TTMS for almost 2 years. Connected with Azure in a number of different ways for over 9 years right now. Mainly within the topics of IoT. I guess this is it. We will be presenting a specific use case today with my colleague Piotr. Piotr, over to you.
Yes, hi, my name is Piotr. I'm working for TTMS as a software engineer for almost 3 years now. And I have 11 years of overall experience in the industry and 6 years with Azure now. Back to you, Maciej.
Okay, thank you, guys. So our overall approach to the migration process, when we approach a customer and want to migrate their assets to Microsoft Azure, is quite structured. So it revolves around making a workshop with client and a close collaboration leading to assessment of their needs in terms of scalability, compliance, and different other aspects important to customers. We want to classify the applications and the infrastructure that the customer already possesses in order to choose a candidate that would work as a proof of concept for the migration process. We typically take the easiest cases first so that we can pretty much see how the process works and what communication paths are required to make it happen. And then we approach to the migrating of different parts of the system next. So basically, we try to slice and dice the system that the client wants to migrate to Azure so that we divide it into parts that can be migrated in steps. And with each iteration, we can take a different approach depending on the specifics of the system. So in general, there are 3 approaches that we recommend to our clients. The first one, they are represented in the columns as on the slide. The first one is we call lift and shift. The second one is redeploy, and the last one is containerize. As you can imagine, those are graduating from the easiest to the most complex one, but also the easiest one provide the least benefits of moving to the cloud, where the most complex ones are providing the most of the benefits. So with the lift and shift, we pretty much take the software and the architecture and try to and the infrastructure and try to represent it in the cloud by virtualizing. That means we create virtual machines, virtual networks, pretty much as they are within the current infrastructure that the client has. That means we can give ourselves the least problems in terms of compatibility between the on-prem and cloud environment. And as close as we represented, the easiest the approach would be. This, however, doesn't give you the most of the benefits from the cloud, because in this lift and shift approach, you end up with your machine that is typically running on your premise within your company, but you will get that machine virtualized in the cloud. That is not optimal for a number of reasons. One of them is cost. The second approach is redeploy. And within that approach, we pretty much try to take the existing code and that the client has, and repack it and readjust it, pretty much modernize it a little bit, so that it fits typically a scenario of Azure App Service, or things like Service Fabric, which will be discussed in the later part of the presentation. But this approach requires a little bit of tweaking with the application and actually looking at the code, making some adjustments. The last approach we call containerize. That means we pretty much think of the application in terms of scalability and redundancy, so that the application can be fitted into a container. We support different containers, mostly in terms of moving the containers to Azure Container Services or Kubernetes services, in where you can easily scale your application. That means running application in a number of instances manually or automatically managed, in terms of providing the best optimal scalability and best cost utilization. So in terms of Azure as it stands right now, there are a number of languages and IDE tools, as you can see on the slide, that are currently supported. So the applications that we talk about are not only limited to the .NET, but also cover things like PHP or even Java. And when you're working with Azure, then a number of IDE tools are also available to you. So it's not only Visual Studio Code or Visual Studio as Microsoft products only. You can pretty much work with any number of tools you want, including IntelliJ or Eclipse. And the same approach is actually applicable to large-scale enterprise applications, as well as very small CMS system, e-commerce systems, or any other service systems that you might be running, that might be both in Ruby, PHP, or whichever framework is actually popular. Also, when you look at the build stage, the Azure infrastructure supports different source code repositories, as well as different continuous integration engines. So as you can see, it's not only Visual Studio Team Services anymore. We've got Azure DevOps as well as GitHub. We support things like Jenkins. There is no limitation as such in Azure in terms of what build tools can you use. And the same obviously applies to the deployment part of the software development cycle. So already mentioned DevOps or slots are supported, but different deployment options too, including the web deploy, the ARM templates you can use, but also very naive and simple approaches like zip deployment or Word deployment, known also FTP deployment. Pretty much we support pushing your Docker or Kubernetes settings directly into the cloud, because those are native to Azure at the moment. So Azure is very much technology agnostic today, and that makes it very viable options for different scenarios. So you can use different Azure tools to accelerate your development. That means using actionable insights and analytics that are ready to use for you out of the box. As I already mentioned, there are a number of built-in CI/CD tools and support for containers. When it comes to the flexibility and choices, this is what I was talking about. Obviously, that starts from the freedom of choice of your operating system, Actually, in Azure, you've got more versions and more instances of Linux machines today than I believe Windows, and these are very well supported. Also, you've got both the Docker as well as Kubernetes services already natively customized by Microsoft and ready to use out of the box with quite clear pricing options. You can use different tools and even different web services and different web servers and different languages as well. So the many benefits I have talked about are about the flexibility and your choices, but there are also benefits like added value that you wouldn't be able to get when running your solutions on-prem. That covers identifying and resolves issues quickly with solutions like Azure Monitor, using AI solutions when it comes to Azure Cognitive Search, and also running things that are not based on Docker images, not based on virtual machines, not based on any other frameworks, except of running pure functions that are very small programs readily deployable to the cloud called Azure Functions. You've got also a number of different choices, including low-code solutions like Logic Apps, where you can pretty much automate simple processes without even coding at all. Okay, so at this moment, I'm handing over back to Jarek, I believe. Jarek, am I right?
Yes, that's right.
Thank you very much, guys. Over to you, Jarek.
Yes, I will share my screen and show the information you just took to us about your experience. So wait a second. First observation is that you are still very shy because only 4 people decided to share with the experience. So we've got 2 architects and 2 other technical roles. So 4 people who already shared are rather technical guys. So welcome to the show. It's especially for you. And when you see this information about your experience, it's half and half. So we've got 50% which ever seen Azure before, and 2 who are mostly more experienced. So let's see how much. Okay, it's a live, so you will see the information will be changed. And what about your experience when we are talking about the time? So okay, less than a year is going more and more. We'll be observing the change in the life, and we've got about 40% of people who are more experienced. Okay. So that's very important for us to conduct this webinar more precisely and more convenient for you. So thank you for sharing your experience. So I'm going back to the studio. So Adam, please take over and going further with the presentation.
Yep. Hello, everyone. Just waiting for the presentation.
Yes, I will show it.
This information from you guys was very valuable, as we are now moving to this part where we will show you the actual use case. So something me and Piotr were part of. We were building, or we were helping a company move from an on-prem system or a set of systems to the cloud. We went through a number of different steps, some of them which Maciej already mentioned. And as I mentioned before, that information from you is pretty important because we kind of know, okay, there are a couple of people who have some experience with Azure before. A couple of you guys didn't have too much contact with Azure, which is also good because we will basically discuss the factors, the things that actually made that company at all think about moving to the cloud. And later on, we will go through, sorry for that, number of decisions we had to make, number of choices, also in terms of the technical side of things. And this is going to be part where Piotr will take over and tell you a little bit more about this technical side of things. I will tell you a little bit more probably about the decision-making process, what impacts that, what may impact those decisions, and we will also talk a little bit about an important topic of what to do when, for example, cloud provider, the selected cloud provider, doesn't support your technology, because this is a very often the case. And we will also discuss some of the challenges. I'm here in the agenda. You can see challenges of geo-distributed applications, because that's basically where we're heading, right? So once you're in the cloud, there are a number of things that are happening behind the hood, and you actually have you may have geo-distributed application right from the start, not really knowing about it at the beginning. So let's get started. I believe this is quite important when migration to the cloud is at all justified, because there's a buzzwords, there are some buzzwords, obviously, and everyone are cloud native today, but I don't think this is always the case. You always have to, I believe, balance things. And we think that a good moment of considering moving to the cloud is when you modernize your system, and when you add some when you want to add some features which are not like features, business driven features, but more like non-functional features, I would say. When you want to think about scaling the app, being available in different markets, providing better user experience through zero downtime deployments, and so on and so forth. This is probably when it's a good moment to think about moving to the cloud. Obviously, when you're delivering software as a service type of applications, where latencies matter, when availability in different regions matter. When you think about geo-distributed applications, again, I mentioned about this latency. This is often something which is missed. So when you think about geo-distribution, usually people tend to think about having backups distributed geographically for different reasons. But it's also about the latency, right? So if the application or if the service is closer to you in terms of geographical, in terms of location, obviously that impacts how the application responds. And probably our favorite part, again, something me and Piotr were doing for a couple of years now. So everything connected with telemetry, IoT, data aggregation, and analysis. There's a lot of services in the cloud that can help with that. And we're actually today wanted to focus specifically on one use case, which was pretty fun journey, I would say. It took a couple of years to take one of the leading European companies from an on-prem system to the cloud-based system. And there were obviously some discussions at the beginning. We started that journey in 2012. So in 2012, I believe, actually Azure started in 2008, 2009, was publicly available, something around that year, I guess. And obviously there was there were some misconceptions, I would say, and not a lot of trust put into the public cloud. So there were a number of, I would say again, considerations. And we were building already at that point, we were building an application where the system, which is more like an internal one, was actually gathering like tons of data. And we had this discussion with our on-prem administrators who told us we cannot keep our clients' data outside of our data center, so our on-prem system. And we told them, sure, no problem, but we will gather like 3 terabytes of data before the end of the year, and this number will only grow. The core business of this company was actually, they were from the industrial branch, I would say. And obviously, their business was to sell devices, right? And the more the device is sold, the more data we would gather. So that was kind of like the first trigger point, I would say, that was okay. 3 terabytes, I mean. So we will have to basically provide an infrastructure for you. And this is not a problem. And Piotr will tell you more about storages in just a second. So that was not a problem in the cloud. Another thing was the availability, because I mentioned about one of the systems, but obviously they had like a customer-facing software. And initially, that software was quite simple, was more or less only dedicated to people in selected countries, but they wanted to go global. And that obviously raised some different challenges, also in terms of, again, supporting infrastructure. Again, going to the cloud is probably a good move when you want to kind of focus more on the business side of things rather than thinking about infrastructure, availability, SLAs, and all that stuff from the clients of your application, for example. One important topic, and I mentioned already about that, the thing with the thing about not security, but more like the handling of the infrastructure itself. Here in that company, they had like very strict rules in terms of the network setup. So they had their on-prem system within company's network, which was actually, I believe, more suited for the employees at the office, right? So they had some rules, so some network setup that was not really suitable for the devices. As we were discussing more about exposing APIs, exposing applications, and also exposing traffic from the devices from all over the world, that was also quite challenging in terms of the network, and obviously all the things that come with that in terms of supporting this. So that was like another thing that that did trigger that thinking of, hey, we probably should think about a more sophisticated solution, I believe, or more reliable solution than trying to put everything into our on-prem system. Obviously, we went through those steps that Maciej already mentioned. So we first wanted to go with the application that we had, because it was actually working. So moving simple Windows services into the cloud, how to move it without really changing too much of a code, and just get some of the advantages of the cloud already. Maciej already mentioned what's the difference between IaaS and platform as a service, but we actually used that lift and shift approach. The next step was obviously full platform as a service adoption, and there were a number of challenges here as well, will be described in just a second. Last but not least, it's always important to estimate the cost. There are some ways. This is not an estimate the cost, obviously, after migration, right? So you probably should think about the cost of the migration itself, but the more important is probably once you're there in the cloud, what are your costs in comparison to the system you have right now? Well, Maciej already mentioned a little bit about this comparison. So in terms of our use case, what we actually had was a set of Windows services and set of VMs running on premise that actually had the MS SQL. So this was more or less the whole system, and we wanted to already take advantage of some of the platform as a service offerings in the cloud, but still not to still not to have to change too much of the code of the application. And that was quite a natural move to go with the lift and shift approach. So take the application as it is, install it in this IaaS format, so move Windows services to VMs. But at that very point in time, already use some of the platform as a service offerings that Azure had, like, for example, SQL Azure. Again, in details, Piotr will tell you a little bit about this more, but what I wanted to mention here is that we were already running in the cloud, so had some of the Azure reliability offerings in terms of infrastructure and handling some of the outages of VMs, monitoring, which is pretty important, and already the SQL Azure, which is basically a managed storage. We also use some of those NoSQL storages instead of our MongoDB. Again, we had a VM running MongoDB. We could move away from supporting this additional infrastructure on our own, so taking care of updates, patches, security vulnerabilities, and things like that. We could focus more on the application itself, but obviously that was not the end of this whole move. The advantage was that we had to barely change the application, right? So we had to more get a feeling of the environment, find out how it works, where to go, how to set up the network, rather than change any of the code. Moving from MS SQL on-prem to SQL Azure was pretty much a switch without any kind of change, just a switch of connection string. That's why this move, this left-hand side move, took us probably like 2 to 3 months. Bigger challenge was this move from IaaS to platform as a service. There were certain challenges, like selecting a compute engine, because then you think about a number of different options. Again, in more technical details, Piotr will describe what were the options that we considered and why we chose the one that we did. But the thing is, here, there are undoubtedly some changes that will be required to be made to your application. You're selecting some sort of way your application is hosted. So you probably should, or in some cases you have to, obey some rules that this compute engine kind of throws at you. So and here probably maybe important or interesting information, when that change from on-prem to IaaS took 2 to 3 months, the change from IaaS to platform as a service was like 9 to 12 months, right? So we had almost like the same application. Obviously, at the same time, we were implementing few new features, but it was mainly about moving. So mainly about kind of refactoring and taking already advantage of the platform as a service offerings. Once we're there, so once our application is actually under full control of a managed compute engine, obviously the sky is the limit, kind of. And again, Maciej already mentioned that a little bit, but I have the link here that would get you to the offerings of Microsoft itself, right? So native Azure cloud offerings, and there are like tons of different services from different storages, different types of storages, different analysis engines, queues, compute engines, hosting offerings. So, and it's obviously not only limited to Azure, but in our case, that was Azure for different reasons again, but our application was written in .NET. We had a background in .NET, so that was kind of a natural environment. Again, it's not only dedicated for .NET people, and Piotr will tell you in just a second about hosting options. But what I wanted to say here is that, again, at this very point in time, you think less about the infrastructure, but whenever there's a new, let's say, feature, and one of such features that we had was something which is probably called geofencing. So basically something that required some kind of notifications. And being on-prem, you probably are looking for some of the offerings of third-party companies. Maybe you're trying to set up something yourself. Here, that was kind of a no-brainer. We just picked notification hubs from Azure, and there we used already ready-to-go infrastructure. All we had to do is just write some code in our application to provide a new feature without really thinking much about the infrastructure itself. I mentioned about costs. Again, there's this neat and quite friendly pricing calculator, which helps you estimate your costs. So when you're moving, and this is what we did actually, like what we did with different components as we kind of traveled through that process of migration. We took each and every component, gave it some estimates, like for example, number of the amount of data that we would like to store. We looked at different storages, we took that pricing calculator and wanted to get as much of the information as possible out of this pricing calculator. It's pretty handy. Again, these are just estimates, right? But in our case, in that industrial area where the company could tell, hey, we're producing or we're selling, because probably they're producing more, but we're selling 70 to 80,000 devices a year. So this is the amount of devices that you can expect over the next couple of years yearly. And each device produces probably like a message every 4 seconds. So this gave us some idea. Okay, this is the bandwidth that we need to be prepared for. This is the storages. That also helped us driven some of the architecture choices, right? Because you're looking at the cost, you're looking at your use cases, and in the end, you are picking the actual well, potentially the best choice right at the beginning, and you already have some estimates of the cost. This is probably this comes really handy in terms of selecting the storage, but also again this compute engines. And this is going to be presented basically right away. So I believe Piotr will now take over and will show you a little bit more in details about the decisions we made within different areas that I already mentioned.
Okay, thank you, Adam. So first, I would like to start with some input information about our case study, very general input informations. So first of all, the project goal of this case study was to deliver IoT solution for HVAC products. It was already a third generation of the product, so we had a really long legacy, including all the dirty tricks and everlasting temporary solution. We've started with a lift and shift solution and headed towards fully managed cloud solution. So initially, we estimated the size of our solution to 30 to 40 microservices. And since the whole solution was message driven, we assumed that we require a message bus built in. Our team was mainly skilled in .NET stack, so this was also kind of a requirement there. And bear in mind that it was year 2016, so some of the options that we have today in Azure were not present yet. Okay, so our first choice was to, our first concern was to choose a proper computation engine. And I would like to mention a few of offerings available in Azure. First of all, we have a group of VM-based products, including bare VMs and also VM scale sets and others like that. They are best suited for so-called lift and shift migrations, but also in some cases where you require some dependency service which is not available in Azure. Another option is App Service. It's already a fully managed hosting environment, fully scalable, but mostly intended to use for HTTP apps, HTTP stacks of many different types. It can host as well as .NET apps, Node.js apps, Java apps, and a lot more. Next option is all the serverless type of computation services. For example, Azure Functions and Azure Container Instances. They are typically used in consumption plan, best suited for small solutions. They have great time to market, but they quickly become very expensive when the traffic grows. And the last option was orchestration services. Here we can find some clusters, like, for example, Service Fabric. In 2016, we had Azure Container Services, but right now it was replaced by AKS, Azure Kubernetes Services, and those are so-called full-blown workload orchestration solutions. Because the complexity of our project was quite high, we decided that just a simple app service is not enough. So we focused on choosing proper orchestration service. And let's look at the first player here. Let's look what's orchestration overall. Yeah, orchestration is a process of providing services in a reliable manner, and it can be seen in 8 aspects. The first aspect is scheduling. So basically, the orchestrator assigns workloads to cluster workers and manages available resources, CPU, memory. Second aspect is affinity, where orchestrator ensures that specified services are run nearby. Anti-affinity means directly opposite. Next aspect is health monitoring. It watches workloads and reschedules them in case of failure. Another one is failover, watches the workers and reschedules workloads to healthy machines in case of node failure. Scaling means adding or removing workload instances to match the demand. Next is networking, provides a cross-machine transparent communication channel. Service discovery enables workloads to find each other across the whole cluster. And the last is coordinated upgrades, which allows upgrade running workloads, avoiding downtime. Yeah, so let's head to the first player here. Our first option was Service Fabric, and what can I say about this particular cluster? So it can run basically any Windows or Linux executable or any Docker container. It was a typical choice for .NET Stack in 2016, since .NET was Windows only back then. Service Fabric has a really wide palette of built-in services. Just to mention, for example, built-in RPC protocol, lots of built-in tools, built-in reverse proxy and load balancer, and also a very advanced programming model, which enables us to create stateful services and actor model services. Service Fabric is widely adopted in Microsoft even now, but on the other hand, has really a poor documentation. Lots of internal staff are literally not documented at all, and has a small community. Our second option was Kubernetes, but in Azure Container Services. Kubernetes is really widely adopted across the whole world, so it has a great community. It is focused on hosting OCI containers, container workloads, which makes it technology agnostic. But unfortunately, as I said, .NET was Windows only back then. It has a simple modular architecture, and the only drawback was that there was no solid offering in Azure for Kubernetes, because ACS was a bit flawed. So this made us to choose Service Fabric, and today we would rather choose AKS, most probably, but still Service Fabric is a really good option if you will focus on .NET stack and your application will be maintained by .NET guys. It's still a really good option. Okay, so that's about it in terms of computation. Right now, I would like to head to another concern. So how to store the data in our solution. So while picking DB solutions, we've been looking at Azure's offer in three aspects. First of all, the experience of our team with the type of databases, at costs, obviously, and about flexibility that the engine offers. And we've been rather looking for general purpose stores. So the offer of Azure is really wide in terms of databases and storages. The list grows basically every day, so I encourage you to look at the links that I've put here. And for the time's sake, I will rather focus on the options that we've actually chosen. So let's move to the next slide. Azure SQL. So basically, it's a fully managed RDBMS. It's geo-replicated, has some built-in backup policies, offers automatic indexing, and one of the most important features here is that it's effortless in terms of moving from SQL Server, on-premise SQL Server. It's not the cheapest option, nor the most elastic one, yet the easiest to move from on-premise RDBMS. There is an option of having other engines, like, for example, MySQL and MariaDB, Postgres, as Azure offering also fully managed. So why have we chosen this one? We've been using SQL Server in our on-premise solution. Actually, it was the first service that we've replaced from infrastructure as a service to actually software as a service model. And the next reason is that we had a team that was really skilled in terms of designing and delivering solutions based on relational databases. Another storage that we've been using is actually Azure Storage. it's a set of services, blob storage, table storage, queue storage, and also file storage. It's a really cheap option in terms of data volume, at least. It has several models of geo-redundancy strategies. As a drawback, it has a really limited indexing capabilities as well as very limited query language. It's not very quick, especially in terms of inserting and updating data, and has hard traffic quotas. But what was the reason behind choosing this particular option? So as I said, it's really cheap in terms of data volume, and literally it was the only option we had back then to store up to 500 terabytes of data. And nowadays, a single Azure storage account is able to store up to 5 terabytes of data. So it's a really good price option for this price.
Yeah, I mean, but you always have to remember about this limit, right? Because
yes, right.
and that probably somehow can be associated with what I mentioned before about kind of estimating, having your estimates or having your estimates in terms of like costs and the number of devices, the amount of data stored, but also in terms of your future feature requirements or current feature requirements. Because, for example, this one is very, very limited in terms of querying capabilities. So you can store like tons of data.
That's one limit, but also the input traffic is capped at 5 gigabits per second, which is not that much when you have a really big data flow, input data flow.
There's actually a number of limits, right? You also have to remember, like with all of those kind of offerings which are very specific, this one, for example, has a limit of number of transactions per second to a single partition. Mm-hmm. And since we were talking about this limited indexing capabilities, you have to choose your partition wisely, right? Because you can have like a global requirement of, I don't know, 30,000 messages per second or 130,000 messages per second, and wrong selection of partition keys, and you're kind of doomed.
Yeah, obviously, you can choose a premium option of the Azure storage, but then it's not that cheap anymore. Yeah, so our last pick was Azure Cosmos DB, which is a really universal storage, multi-API storage, which supports SQL-like query language taken from old DocumentDB. You may remember this store. It has a MongoDB API, as well as Cassandra API and Gremlin GraphDB API. And the last one is Table Storage API for those rare cases when the capabilities of Azure Storage is not enough for you, then you can switch from this option to Azure Cosmos DB. Yes, another thing is that it has sub-millisecond latency. It offers also lots of geo-replication strategies, almost unlimited scaling capabilities. That's really a thing here. But yeah, this option generally starts to be expensive quite fast.
That's right. That's right.
You have to really take care when choosing the partition key of the collections, because a single physical partition has a limit of 20 gigabytes of data, and cross-partition queries pumps the cost really fast. Basically, it comes with a billing model where you pay for every query.
So well, probably that example with Cosmos DB is actually one of the major problems we actually faced when moving from MongoDB to Cosmos DB, because we selected that as a storage for some of the logs from the devices, and we were quite happy with the choice. We thought, hey, 20 gigabytes is pretty much all that we need, and in the end, this was actually like one of those major problems that we faced, and it was already there in production. Luckily, this wasn't like more than 20 gigabytes at this moment, so we could actually pretty quickly migrate from the single partition to multiple partitions. But yeah, that was a surprise, I would say.
Yes, yeah. Basically, we've used it for an event view on our UI where we needed really low response times, and we've been querying quite a lot of data. So. Yeah. So let's maybe head to another subject because this concludes the topic of databases and storages. Yeah, my technology is not available in Azure offering. Then what can I do? So let's head back a bit to our case study. As I said before, our system was built in a message-driven model. So the previous generation of the system was utilizing an on-premise cluster of RabbitMQ as a message bus, and it turned out that RabbitMQ is not available in the Azure catalog. So what next? Our next step was to pick something that was similar to RabbitMQ. Azure offers a service called Service Bus. It also implements AMQP protocol, but in the end, it turned out that it was a different version of the protocol. So at first glance, it looked like it will fit our needs perfectly. Unfortunately, after short assessment, it turned out that it does not play well with our solution for two reasons. As I said, the AMQP version was a different one. Service Bus delivers AMQP 1.0, and RabbitMQ implements an old version. It was
0.9.
0.9.
Yeah, so that was quite also something which surprised us, because obviously we thought, hey, Service Bus is 1.0, but they are largely incompatible. So we would have to rewrite the whole application basically, which wasn't really the best choice.
Yes, it was not the only limitation here. We've been using topic subscriptions in a manner that Service Bus wasn't able to handle because it has some limits on that. And we've been subscribing topics like, for example, by 20,000 of consumers.
Yeah.
So, So Service Bus was not a great fit for us. So what next? Then we've headed to Azure Marketplace. So it contains lots of third-party offerings. This way, we have found and managed an AMQP service based on RabbitMQ. This also looked really good for us, but in the end, it turned out that the performance of the solution is not enough for us. Our on-premise cluster was really performing a lot better. So the last result option is that we've created our own cluster based on VMs, having also in mind that the whole hassle around maintenance of the solution was on us. It was our duty to do it. But in the end, keep in mind that if everything else fails, then there's also an option like this. And yeah, that's it from my side. Back to you, Adam.
All right. Really, just one last thing I wanted to share with you. So some of the challenges that geo-distributed applications present, we were quite surprised by a number of things. So again, when you're moving from on-prem solution where you're serving from a single country, things like, for example, legal restrictions related to data storage may appear. And this may be quite surprising because some of the, well, most of those storages that Piotr mentioned, they provide you with geo-distributed redundancy. And all of a sudden you can kind of break some break law, simply putting it simply, by keeping data of users from particular country in a different country than they are originally from. So these are the things like hardware and software limitations. And what I mean by that is like some of the countries, for example, require you to have data encrypted, and not only the communication must be encrypted, but also the data which travels through the wire or over the air has to be encrypted. So things like that, and then obviously your cloud and your device has to somehow cope with that. And one additional thing, this is more like not a challenge, I would say, but more like an advantage. I've already mentioned that, but it's probably worth again kind of emphasizing that whenever you think about globally distributed application, it's probably good to have your data and your services as close to your clients or potential users. Microsoft and Azure, they come with probably 54 or even more of the regions where you can put your applications. At the same time, mind that not all of the regions actually come with the same set of services. So you may be surprised that, for example, our choice of AKS or Service Fabric or different type of storage was available in one region, but wasn't really available in another one. So this might also be challenging. That concludes the part of of our use case analysis. Hopefully, some of the information here provided here will be useful to you guys, and you can somehow bounce off of it. Thank you for staying with us. Thank you for listening. Jarek, I believe now back to you.
Okay, thank you guys for the presentation. I will just summarize some points. So I've just put the information in the chat, and we'll go back in the next slide. But for the next steps, we are the expert in Azure, so contact us if you've got some additional question on or better you want to go deeper into your solution and into your business needs. So we are specialized in the IoT, AI, modernization of the legacy apps, as you can see, and custom apps development. We've got the special, of course, a different team of Office 365 teams and Microsoft 365. So if you've got anything on this area, please contact us also. But we must go faster. So if you want to take a chance into the have some awards, please take second and go to the questionnaire we've got. You've got the chance to scan the QR code or just go to the chat and click on the link. And that's only 2 questions, so it's easy to say. We've got a prize for 4 hours for free consultation. So take a look and give you a chance to win. So thank you again. We are waiting for your response. If you've got some comments or feedback, please share us with the questionnaire or even on the chat. So again, thank you very much, and see you again. Bye bye, and thanks again for the presenters. Thank you, guys.
Thank you. Thank you, and see you soon.